I'd like to introduce our next speaker, Sridhar. Sridhar is a senior software engineer in the Azure Security Data Science team, wherein he ships high-performance, scalable machine learning solutions for Azure security services. Everyone, please welcome Sridhar.
Everyone. So there have been a lot of talks about false positives today, right? That's definitely a problem that system analysts faced in mid-sized to large enterprises. And here are some numbers, actually. A mid-sized company spends around 21,000 hours per year, chasing false positives, and that costs them around like $1.3 million a year, right? So this is definitely a problem, and there are multiple speakers who talked about this today. So what is the solution for that? We want to enrich our security alerts with additional metadata, right, that can help you deal with false positives, increasing the alert fidelity and help you to mitigate or resolve your alerts as well in a quick manner, right? This talk is going to be about enrichment. I just want to quickly go through our main goals, on why we want to do enrichment. The first thing is we want to reduce false positive, as I told before. We want to make sure that we provide extra context to your alerts so that you can confidently say something is a false positive or not. And then also the second is we want to reduce your mean time to resolution of your alerts to help your investigation, and also to focus on investigations on alerts that are important. Not all alerts are the same, right? And also help increase the expertise of the SecOps team and make them think think in terms of graph, right? So I know there's been a lot of talks about there was the famous John Lambert blog as well, attackers think in graph, defenders think in list. So we are nudging, with this enrichment, our goal is to nudge defenders to think in terms of graph. So today we do in my team we do two types of enrichment. One is the peers. The peers are networks of users within your organization, right? And the blast radius. For now, I'm just going to say it's a graph representation of all your assets and entities and the relationships between them in the cloud. But we'll go in more detail about that. Okay. First, the peers. So who are your peers in your organization, typically? The people you collaborate with, and they're mostly the people whom you share access to resources with, right? So we have defined peers like this to find your network of users within your company. The next thing is since we are in Azure security, does Azure has information about your peers? One of the things is that we can use is the Active Directory hierarchy information that is available in Azure. But we found that we actually did some investigation. We found that not a lot of companies set this up in Azure. In fact, only 40% of companies have at least 20% of users in their hierarchy. And also guest users, I don't know, if you know about business-to-business users, B2B users from other tenants, they're not usually part of an organization, so they get left out. So we decided that is not the right approach to take. So at least it won't solve all the scenarios that we want to solve for. The next is groups. There's support for groups in almost every major directory offering, and Azure also has it. And a lot of organizations use groups for mailing list or security groups for admin access and all these kind of things. So groups are very common, so we wanted to take that approach to find people who your peers are. Now, how do you find peers from your group? So people with whom you share common groups are most likely to be your peers, right? And also we take transitive membership into account. Azure Active Directory supports nested groups, so we have to take transitive membership also into accounts. And we ignore large groups. Like if you belong to a large group, the assumption is you're not going to work closely with everyone in that group. So the inverse is like, smaller the group, more likely you're to collaborate with them. So these are all assumptions like on how we can find peers from group membership details, right? So what do we use? We use an algorithm called term frequency inverse document frequency. It is a text processing algorithm. So let's say that you have millions of documents and you want to search for the phrase, the Lord of the Rings, right? So terms like the and of are like, terms that occur very frequently. So documents with those terms are actually prioritized less in your search results. Whereas terms like rings and Lord, those terms occur less frequently, and they are weighted more. And documents with those terms are prioritized more in your search results. Right? This is like a really simple text searching algorithm, and a version of that is what we use for calculating your the peers. So we provide we get normalized weights for groups. Smaller the group, higher the weight. That's how we deal with it. And the output of this algorithm is like a ranked set of peers for a user. So just to give go a little bit deep into it, here you can see a Venn diagram of group membership details. Really simple one. So who are the peers of the green user, right? I'm hoping it's obvious here, but the closest peers are the couple of blue users that are there because they share all the three groups with them, right? Okay, who's going to be the next closest set of peers? The red users, they share a couple of groups, the orange users as well, the yellow users as well. But the way we rank peers is that we provide weight to smaller groups. So the next set of rank of peers would be like the red users because the common groups are smaller, right? And similarly, like the next in the rank would be the orange user because the common groups are like smaller than the yellow users. So this is how we rank the peers. So how good is this algorithm? Like, I don't know, like maybe people at Microsoft can recognize these names. So this is the executive leadership at Microsoft. So this network was created completely from group membership, nothing else, right? So as you can see, Satya is the CEO. I picked up the top 5 peers for Satya, and then their peers and created this network. So as you can see, like Satya is a CEO, and he has like Amy Hood is the CFO, Brad Smith is the chief of legal affairs, and Scott Gu is the head of cloud in Microsoft. So so we were able to find out say that, hey, this algorithm works pretty well with the data at Microsoft. We're also trying to get feedback from our customers regarding this. But yeah, this is completely based off like the TF-IDF algorithm. Okay, now we have calculated peers. Now, what are the use cases in security? Like, what do we do? How can we use them? Let's take that there's a user called John Doe, and this user, and the purple nodes here are users. Like there's a user called John Doe, the purple nodes are users, and it's his peer network. Like, let's say if there's an alert trigger due to some anomaly activity from John, right? So as a security analyst, what do you do with this? One thing that we can help out with is like, if it is in line with the peer activity, if the peers have done the same kind of activity, then you can suppress that as a false positive. That access is usual for this peer network, so there's probably nothing. Maybe this is a low fidelity alert, and then you can suppress this, right? If not, if the access is not in line with peer activity, then there is something suspicious happening. Right? So in that case, you can you can say that this alert needs further investigation as well. Right? So this is like one of the use cases for peers. I mean, there are a bunch of other, and like when you think about it, like there was a teammate who joined our team recently, and then like as we do this calculation every day for peers, and then she suddenly shows up like once she's onboarded to with the new hire document and everything, and then she shows up as my peer, like. And we found out that one of her peers were members from the older team, from her older teams, and we were able to make sure that she was removed from her older groups appropriately as well. Like there are a lot of use cases for this, but this is like one example, and like for reducing false positives. Like that was one of the points, like one of the goals for enrichment. And next we're going to move on to blast radius. So I think people were talking, like some of the speakers were kind of like talking about similar things, but here we go. So what is blast radius? So we are defining it as privileges of an entity in your cloud environment. It must include hidden and transitive privileges as well. I think an entity here could be anything like a user or a group or even a virtual machine in your cloud, right? And blast radius should be able to answer the question, what is the full impact if an entity in your organization is compromised, right? That is also important. I mean, that's one of the main goals here. And it helps to think of blast radius in directed graph. The nodes can be entities in your cloud. The edges could be relationships, and there can be multiple edges between nodes. And the edges can carry all kind of information, like what is the access level what is the type of access between the entities, when did they start, when did they end, so that you can maintain history also, right? So, so directed graph is like a really good way to represent blast radius. So let's go a little bit into it. This is like, every cloud environment is complicated. Like these are like a sample of services that are offered in Azure, right? And they all interact with each other in like complicated ways, or I would say not very obvious ways. It's easy to misconfigure something or lose track of something, right? And that's where we want to help out, like with our security expertise as well. So I'm just going to give you an example here. This is a sample blast radius of a user, right? So the purple node is a user. The green nodes are subscriptions. A really simple explanation, I don't know like how many people are familiar with Azure, but a really simple explanation is just a collection of your Azure resources like VMs or storage accounts, your web services, right? So any permission you have on a subscription, it actually propagates to those resources as well. The brown nodes are groups. Groups are kind of, it's easy to configure all your team members in a group and provide them access to a subscription. That's like a standard way of doing things. And I'll talk a little bit about service principal, but before that, let's, this is the blast radius about for the user. I mean, like, I'm hoping it's obvious. Like, this person, Jane Doe, is a member of this. So this person, Jane Doe, is a member of this group, core HR team, and as a result of that, she gets permissions to a bunch of these Azure subscriptions. The goal is to capture these, relationships in a graph manner, in a graph-like visualization. So let's say that you received an alert for this user, right? And you want to. Like I'm going to talk about, like, you received an alert and you want to, that this alert is positive, right? And you want to like revoke some access for this person, right? I'm talking about your mitigation steps here, right? So let's say that you want to remove access to this particular subscription. So what do? This graph helps you to find all the edges that go from that user to that subscription, and you can make sure that you cut off all the edges that lead from that user to that subscription. So in this case, you have to cut off the access to this group as well, because there is like, a reader access coming from this group has reader access on the subscription, and also one more. one more group, because this group also has a reader access to the subscription, right? So this is like one example on how we can help you with your mitigation. The next example would be service principal. Like, service principals are really useful in Azure. So, okay, let me explain what a service principal is first. They are just another identity in Azure, like, so kind of like a user, right? You have credentials for a service principal. In fact, you can have more than one credential for a service principal. And you can, it's primarily used for automation. You can assign, like, your service principal's specific privileges, and you use it for automation, right? You don't want to use user accounts for that. You don't want to maintain passwords for that, like create accounts, user accounts, and maintain passwords. Service principals are a really good way of doing those automation, securing your automation as well. In principle, a service principal should never be authenticated by, a user should not be using a service principal. It should be completely automated, right? If a service principal is getting the auth token from your token server, it should be done, it should be from a script that is running inside your automation. In principle, yeah, a user should not be using a service principal. Of course, that's not the case. And service principals are also an interesting attack vector for hackers, right? So remember that it's just another identity in Azure. So what this means is when a service principal performs an activity in Azure, your Azure audit logs will have the identity as that service principal, right? It won't have the identity of the user behind that service principal. Right? So they can easily mask themselves if they gain access to a service principal as well. So having said that about service principal, it's important. I've seen a lot of people, like, it's an interesting entry point into your cloud infrastructure. I've seen a lot of times where it has been misconfigured or over provisioned with credentials and all these kind of things. So in this case, let's say that you want to revoke access to this particular subscription, right? So of course, for that user, you will have to remove access to that group as well, but you will have to make sure that you remove access to the service principal as well. Today, this is not very obvious in Azure, but yeah. And the other aspects is, like, you can pivot around a subscription here. Here it shows the blast radius of a user, right? So you can pivot this graph around a subscription, and then you can see how many attack points are there. Like, what is the attack surface of that subscription? Like, how many users can potentially have access to your subscription today, right? So that would be useful for compliance purposes. For example, like, you make sure that only your team should have access to your subscriptions, right? And you want to make sure that you cover all kinds of entry points into your subscription, right? So that's one of the use case for this. In the end, like, this graph, our goal is to provide this information in this graph-like manner, so that you can once you're somewhat positive about your alert or investigating your alert, you can take necessary mitigation and remediation steps, right? So that is the main goal here. So just a small plug here. Both this data is something that we do, analytics is something that we do today. If you're an Azure customer, if you use Azure Sentinel, it is available today just as a private preview feature. You can contact me or Ram. Actually, Ram is the PM for this feature. Yeah, you can contact me or Ram. The way it works is Azure Sentinel is built on top of, like, log analytics. Log analytics is a columnar database available in Azure. So we push all this data into log analytics, and then you use something what is called as a Custo query language to extract the data. In fact, this visualization that I provided in the previous slide is actually, the way it is done is, like, we retrieve the data from the Custo query in a Jupyter notebook, and then we display the result of that query in a graph-like manner using some JavaScript libraries. Right? That Jupyter notebook is actually available in a public GitHub repo, but I forgot to include the link here. But I'll make sure I'll include the link before these slides are uploaded to GitHub as well. So yeah. So if you're interested in this, you can talk to Ram or me. Meanwhile, like I'm at the end of the talk. I know it's been pretty quick, but if you have any questions, yeah. Okay.
Does anyone have any questions?
All right.
All right. Please join me in thanking Sridhar.